Okay, guys. Today we're going to talk how to do an empirical formula problem, and this is like the two-step kind, where it asks you about both empirical and molecular formula. So let me read this here, and here, take a look at it because it's hard for me to read. So a compound is 19.3% sodium, 26.9% sulfur, and 53.8% oxygen. Its formula mass, so the actual mass that we measure in the laboratory, is 238 grams. What is the molecular formula? So there are a couple of things that they're wanting us to figure out here. So here's my strategy, is to, one, find the empirical formula. And then once I know the empirical formula, I can add up the empirical mass. And then I can compare the empirical mass with the molecular mass and see if that's, equal or if it's some sort of multiple. Okay? So the steps to finding empirical formula are like this. I'm trying to do this so we don't, get ahead of ourselves here. So at this point, you can go and try the problem. Stop the video. I'll have the answer when you're back. Okay, so the steps to find the empirical formula, you should memorize these. This should be something that, they're not going to give you the steps for this on the AP exam. And what you can look at is the sorry, I just got an email saying that last year's AP responses are available. I'm thinking, do I want to go see those or not? No, I want to finish this video. So finding the empirical formula: 1, solve for moles. 2, divide by the smallest number. Okay, so the smallest number of moles that you get, there's always going to be one number that's the smallest. If they're all three the same, then just divide by that, because even if they're all three the same or all both the same, they are the smallest, okay? And then adjust with multiplication. Like if you get a 0.5, you can't just round that back. That has to be multiplied by 2. If you get a 0.33, again, you multiply everything. You don't just adjust one. That will get you into trouble. If you do it for one, you have to do it for basically everyone, okay? So if you would have one that has a 0.5, you multiply them all by 2, or you're going to get a really weird answer. Okay? So here is kind of how to solve the problem. I'm going to put this up again on my clipboard so it's easier to see. Okay, so what you see me doing here is there's your sodium, there's your sulfur, there's your oxygen, there's me switching it to moles, switching it to moles, switching it to moles. And look, switching to moles is easy, people. So what you got here is 1 mole over the mass that I just got from the periodic table, 1 mole mass from the periodic table, 1 mole mass from the periodic table. So that gives me 2 answers of 0.839, and then 1 answer of 3.36. Obviously, the 0.839 is the smallest, so I divide everything by 0.839. This one works out perfect. It's really easy. It gives me a 1, a 1, and a 4. Now, I'm a little suspicious of that, just being a chemist, and I'm thinking, I actually went and checked, because normally you would have 2 sodiums and you would just have sodium sulfate. But I double-checked my math, just like, hey, if you get a weird answer, double-check your math. And everything came out right, and so I had 119. And so all I did was I added up 1 sodium, 22.989, 1 sulfur, 32.07, and 4 of the oxygen. 16 times 4 is 64, and that adds up to 119. They give me the 238 at the beginning of the problem. I take 238 divided by 119, and that is 2. So I take everything here, multiply it by 2, Na2, S2O8. This is something called sodium persulfate. Kind of uncommon, but it is a viable compound, and it is the right answer.